Hey everyone, and welcome to This Explainer. Have you ever actually stopped to think about the literal invisible magic that happens the second you walk into a coffee shop or an airport or even just your own living room and your smartphone just magically connects to the Wi-Fi? You don't have to configure a single thing. You aren't sitting there typing in lines of code. It just works. Well, today we're going to unpack exactly how that happens by looking at one of the absolute most important protocols on the entire internet. Let's get right into it. Section 1. The Static IP Nightmare. Okay, so to truly appreciate the sheer brilliance of how our devices connect today, we kind of have to look at the alternative first. To get online, every single device on the network absolutely requires 4 manual settings: an IP address, a subnet mask, a default gateway, which is basically your router, and a DNS server. Now, back in the old days, a human being had to physically type all 4 of those pieces of information into every single device by hand. Just imagine the absolute nightmare of doing that at scale. Picture a massive corporate office, or maybe a university campus with, say, 10,000 students. If you had to physically type those 4 separate settings into 10,000 different student smartphones and laptops, it would be impossible. You'd literally need an army of IT professionals working around the clock just to get people online. And honestly, the manual labor isn't even the worst part of it all. What happens if in all that endless manual typing, a network admin makes a tiny, tiny typo and accidentally gives 2 different students the exact same IP address? Well, it creates the dreaded IP conflict. See, in a network, an IP address has to be entirely unique, no exceptions. If 2 devices claim the exact same address, the network gets totally confused, and neither of them can connect to the internet. The whole system just fails. This right here proves exactly why the manual method is absolutely impossible at scale. Which brings us to our solution. On one side, you've got the manual nightmare of hard-coding static IP addresses and risking those network-breaking conflicts. But on the other side, we have the automated brilliance of DHCP. So instead of permanently hard-coding an IP address into your device simply leases one from a central server automatically. It's temporary, it's perfectly organized, and the best part, it happens completely behind the scenes. Section 2. The VIP Ticketing Booth. Okay, let's dive into this. To really visualize how DHCP, which stands for Dynamic Host Configuration Protocol, works, I want you to imagine the network as this vibrant, glowing digital nightclub. Think of the central DHCP server as a highly efficient, robotic VIP ticketing booth sitting right at the entrance of this club. When a new device, like your smartphone, walks into the network's lobby, it isn't just allowed to walk straight into the party. No way. It has to get a valid ticket from this robotic booth first before it can actually join in. Section 3. The D.O.R.A. process visualized. So how does your phone actually get that ticket from the robot? Well, it secures this VIP pass through a pretty fascinating 4-step conversation known as the D.O.R.A. process. That acronym stands for Discover, Offer, Request, and Acknowledge. We're going to follow a single smartphone's journey, step by step, through each of these 4 distinct phases to see exactly how it gets clearance to join the network. Step 1 is Discover. So your smartphone connects to the Wi-Fi. But because it has no IP address yet, it's essentially blind. It has literally no idea where the ticketing booth even is. So visualize this. Your phone's avatar walks into the dark lobby of the nightclub and just shoots this massive glowing white flare straight up into the sky. In networking terms, we call this a broadcast. That flare is basically shouting to everyone in the lobby, "Help, I am new here. Are there any DHCP servers out there?" And that flare brings us right to step 2, Offer. Now, what's really interesting is how the server responds here. That robotic DHCP ticketing booth sees the bright white flare, turns around, looks into its digital vault of available IP addresses, which we call the DHCP pool, grabs one, and holds it out. Picture the robot projecting this glowing green VIP pass. Let's say it has the numbers 192.168.1.50 stamped on it, right towards your phone. It's essentially saying, "Hey, I am a DHCP server, and I can offer you this IP address." Your phone sees the offer, and it's thrilled. But here we hit step 3, Request. Instead of just quietly whispering back to the robot to say thanks, your phone shouts out again. It shoots off a second bright broadcast flare. Now, why on earth would it shout? Well, because in a massive enterprise network, there might actually be multiple ticketing booths operating in that lobby just for redundancy. Your phone needs to formally and loudly tell all of them which specific offer it chose. That way, the other booths know they can put their unselected tickets right back into their vaults. And finally, we reach step 4. Acknowledge. The DHCP server hears the request and finalizes the whole transaction. Visualize the robotic clerk taking that green VIP pass and stamping it. But it doesn't just hand over the IP address. It also hands over the default gateway, like 192.168.1.1. And suddenly, this glowing countdown timer appears right on the ticket. The booth says, "Confirmed, the IP is yours, and you have exactly 24 hours until this pass expires." Section 4. The magic of leases. Now, you might be wondering, why on earth does the ticket have a countdown timer instead of just being permanent? Like, why doesn't the network just give your device the IP address forever once the D.O.R.A process is complete? So the crucial point here is that a network only has a limited number of IP addresses in its vault. Think about a busy local coffee shop. If you go in, get an IP address, and then leave an hour later to head home, that coffee shop desperately needs that IP address back so they can hand it to the very next customer walking through the door. DHCP leases are what ensure that addresses are always returned and recycled. When your lease timer hits 0 and expires, your VIP ticket literally turns to digital dust. Poof! That IP address goes right back into the DHCP pool vault to be handed out again. But hey, don't worry. If you're actually still sitting at that coffee shop working away when the timer gets low, your device is smart. Well before the ticket turns to dust, your phone will quietly ping the server and just ask to renew the timer. This ensures you never get abruptly kicked off the internet while you're still there using it. Section 5. CCNA Quick Recap. So, we've covered a lot of ground here today, right? From the whole static IP nightmare to the VIP ticketing booth. Whether you're just a tech novice trying to understand why your home Wi-Fi works, or an IT student cramming for your CCNA exams, here is a rapid-fire review of the key takeaways. First, DHCP. This is the protocol that automates the assignment of your IP address, subnet mask, default gateway, and DNS servers. Second, D.O.R.A. That's the 4-step conversation: discover, offer, request, and acknowledge. Third, the DHCP pool, which is simply the vault or range of available IP addresses the server can hand out. And finally, lease time, the countdown timer dictating how long your device keeps the IP before it has to renew it or return it. And this brilliantly illustrates how everything in modern connectivity connects right back to that automated VIP booth. It really is a beautifully elegant system. But as we wrap up this explainer, I want to leave you with one final thought to ponder. We just looked at how the D.O.R.A protocol works for a single smartphone walking into a lobby. But imagine the scale of the modern world for a second. What happens when millions of devices are fighting for leases in a massive public space, like an Olympic stadium or an international airport, at the exact same time? The invisible, massive scale of digital networking happening all around us every single second of the day, it's truly mind-boggling when you think about it. Thanks so much for joining me on this deep dive, and I'll catch you in the next explainer.